All right, here we have section 9.1. So we're moving into a different chapter here. And so we're looking at square roots of a number. All right, so if you remember a square root, when we take the square root of a number, we're trying to figure out what number times itself equals that number that we're taking the square root of. So we have, if b squared is equal to a, so b times b equals a, then b by itself without the square on it would be the square root of a. So for example, if 3 squared is equal to 9, 3 times 3 equals 9, then 3 would be the square root of 9, because that is the number that we multiply times itself to equal 9. All right, so now one concept we have to think about that you may not have been taught up to this point is that now that we deal with positive and negative numbers in algebra, there is always the possibility that a number has two square roots. All right, you can have a positive square root, which we call the principal square root, because that's what we usually think of when we think of a square root. We think of what is the positive number that multiplies times itself to equal that number. But there is also a negative square root, because just like up here where 3 times 3 equals 9, if I did negative 3 times negative 3, if I multiply those two together, the negative, since there's two of them, would become positive, and 3 times 3 is 9. So negative 3 times negative 3, or negative 3 squared, would also be a square root of 9. So square roots are written with a radical symbol, right? The little check mark looking symbol. My computer program doesn't make the line that goes over the numbers, so if you see just the little check mark there, everything behind that should be underneath the radical, as we would say. All right, the number or expression inside the radical symbol is called the radicand. So whatever we have underneath here is the radicand of the number, and this symbol here is a radical. All right, so if I have a positive square root, it's just a square root with nothing in front of it normally. All right, so square root of 9, positive square root is 3. We can have a negative square root. So the negative square root of 9 is going to be negative 3. Square root of 9 is 3, and negative 3 times negative 3 would be the square root, negative square root. And then you can have a positive and negative square root, right? Just like we discussed, there's two possible square roots. So we can use that with a symbol with a addition sign or plus sign over a negative sign in front of the square root. So plus or minus the square root of 9 is how we would say that. Plus or minus equals plus or minus 3, or you could break that up. This symbol plus or minus 3 is the same thing as saying positive 3 or negative 3 is an answer. So this little symbol here kind of simplifies what we have to write. We only have to write the number once, and plus or minus in front of it tells us that there's two answers, the positive number and the negative. So when a number's square roots are integers or quotients of integers, we call those perfect squares. All right, so when we take the square root, it's a whole number, an integer that doesn't have decimals or fractions in it, then it's a perfect square. So now we're just going to look at these terms, take the square roots of them. The square root of 81. So square root of 81, if we know 9 squared equals 81, right? So 9 is going to be our square root. Negative square root of 81 is simply going to be the same square root of 81, which is 9, but this time we're putting a negative in front of it, negative 9. Negative square root of 0. The negative's there. If I take the square root of 0, what times itself equals 0? 0 times itself would equal 0, right? So negative 0, which we really can't have a positive or negative 0. It's a neutral term, so it's just going to be 0 for our answer. Plus or minus the square root of 0.0016. So you might have to use a calculator on some of these. So plus or minus, and the square root of 16, we all know, hopefully know that 4 squared equals 16. And since we have 4 decimal places, we would be multiplying something with 2 decimal places times something with 2 decimal places to end up with 4 decimal places, if you can remember your rules for multiplying decimals. So 0.04 would be our number there. Might need a calculator for that one. And the square root of -9. Now, we have a negative underneath the radical. The problem with that is we're looking for a number times itself that would equal -9. And in this case, or in any case, we can't multiply 2 of the same number and get a negative, right? If you multiply 2 negatives together, you get a positive. If you multiply 2 positive numbers together, you get a positive. So this is something we call undefined. We're not able to take the square root of a negative number. So that's an undefinable thing. We can't do it. All right, so a few more to deal with. Might be a little more difficult. Might need a calculator on more of these. Maybe not the first one. Negative square root of 36. Negative. And square root of 36, or what number times itself equals 36, is 6. It's -6. Square root of 1.21. Take a calculator, and that's going to give us 1.1. Negative square root of 0.04. So negative square root, so the answer is going to be negative. And 0.2 times 0.2 equals 0.04. And then 8, right? 2 times 2 equals 4, 3 times 3 equals 9. 8 doesn't have a perfect square root, so this one's one that we definitely want to use a calculator with. And if I plug that into the calculator, I'm going to get a number like 2.828427 as the square root of 8. And so I'm not going to write the whole number. I'm just going to round it to the hundredths place and say that this is about 2.83. Right? From the 2, you look to the right, it's an 8, so we round it up, 2.83. All right, so a quadratic equation is going to be an equation that can be written in the following standard form. ax squared plus bx plus c equals 0. So in this equation, the x's are actually variables in the equation. A, b, and c would be numbers, real numbers that we would have in those places. So we'd have a number in front of x squared plus a number in front of x plus some other number equals 0. Is the standard form of an quadratic equation. The a right here, since it's in front of at the very beginning, in front of the x squared, is known as the leading coefficient, which should make sense. It's at the beginning. Now, when our b is equal to 0, right, if I have a 0 right here where the b is, then I have 0 times x. And 0 times anything is 0, so it would cancel out that term. So if our b is equal to 0, we end up with ax squared plus c equals 0. So if we end up with an equation with the x squared and maybe just another number equal to 0, then we can actually solve those using square roots. All right, if it has a b in it that's not 0, then it gets a little more complicated to solve it. But so, if I want to find the square roots of each side here, so this x squared equals 16. So if I take the square root of both sides, right, then the square root of x squared, that gets rid of the square on the x squared. That gives me x. Now, what we have to keep in mind is we are inserting this, so we want all possible solutions. So we're going to actually introduce a plus or minus sign here in front of the square root of 16, because the square root of 16, the positive value and the negative value, could both be a solution that we could plug in for x squared and get the answer. So square root of 16, hopefully we know that 4 times 4 equals 16. So x is going to equal plus or minus 4 here. Or you could say x equals 4 and negative 4. Right? Two different ways to write it. Same possibility. 4 times 4 equals 16. Negative 4 times negative 4 equals 16. All right, x squared equals 11. So take the square root of both sides to get rid of the square on the x. If I take the square root of the 11, once again, I'm going to put a plus or minus in there. Now, 11 doesn't have a perfect square root, and in most cases, we'll leave the radical in the equation unless it tells you to round it to a certain point. So this is going to be x is equal to plus or minus the square root of 11. All right, and that's about as far as we can take it. Or you could say x equals the square root of 11, or the negative square root of 11. All right, x squared equals negative 4. So in this case, when I go to take the square root of both sides, plus or minus in front of that square root when I take the square root of negative 4. Now, one kicker here is that we have that negative symbol there, right? And so, just like when we had the square root of negative 9 a minute ago, that's undefined. We can't take a square root of a negative number. And so, here we're going to say no real solutions. And we say no real solutions because when you get further into algebra, you'll learn about something called imaginary solutions. But we're not going to go any further with those. If we're taking the square root of negative, there's just no real solution. All right, so then x squared equals 100. Take the square root of both sides. Put the plus or minus with it. And so x is going to be plus or minus, and what number times itself equals 100? That would be 10. Right, so x equals plus or minus 10. Or x equals 10 or negative 10. Either one of those would be a solution. All right, so then this last example, we're actually going to have to work to get the x by itself. So we've got 120 minus 6 x squared equals negative 30. So we want the x squared by itself. So first thing we're going to do is subtract 120 from both sides. It's going to give us negative 6x squared equals negative 150. Then we need to divide by the negative 6, which is going to give us x squared equals negative 150 divided by negative 6, which is going to give us 25. And then take the square root of both sides to finally get the x to be an x without an x square on it. When we insert the square root, we insert plus or minus with it. So 25, hopefully we remember from 3rd grade, 5 times 5 equals 25. So x equals plus or minus 5, which is the same thing as x equals 5 or negative 5. All right, so that completes section 9.1.